In the last video, we did get through learning a little bit about topic 2.4 and we did number 1. Just in review real quick, we learned that quadratic equations graph make a parabola. There's two forms that you're going to see these equations presented to you. They will either be in what they call quadratic equation form or standard form, and that looks like this. The form that they're in dictates how you find the vertex. If it's in quadratic equation form, we find the x part of the vertex by taking negative b over 2a. And then we take our x part and plug it into the expression to find the y part. That's what this means. If it's in standard form, you don't have to do as much math. We just always take the opposite of the h value because of that minus sign that's in there. So when we pull it out, we want the opposite sign. If there were a plus sign, 3, we take out a negative, whatever. And then the same sign of your k makes your y value of your vertex. So reminder again that your max and your min, it comes from your vertex. If it's your max is your highest spot, and that would be if the graph is going down, and your min is your lowest spot, and that's if the graph is going up. Max if it's going down, min if it's going up. Kind of set it backwards compared to that. And we know if a graph's going up without doing anything by just looking to see if the a term, like the leading term, is positive, then we know it's pointing up. If it's negative, we know it's pointing down. And so this just reviews basically how to find the x-coordinate of the vertex, which is your axis of symmetry. So there's a lot of things that pair together and answer kind of the same thing using the same thing. Our range is always our y-coordinate part. Okay, your axis of symmetry deals with the x part of your vertex. The range deals with the y part of the vertex. So you did example 1, or we did example 1 already. Kind of going through all those things to answer some questions. Now in WebAssign, you're never going to have to do all of them. They may just ask you what direction is the graph going, or what's the max or the min, which means you need to go find the vertex. So you have to kind of understand what each part is to be able to answer it like we are on all these separate questions for each graph. So we're going to go do number 2 and 3 now. Okay, so if you look here at number 2, this equation is given to us in what's called standard, or not standard, but it's called quadratic equation form. So if we are looking at this one, going through the steps up there, the first thing I like to identify is, does this graph open up or down? Since this is positive, we know it opens up. So that's just answering the first thing like we did above in number 1. Always do it in the same order, or almost always. The second thing I'm going to go identify is the vertex. So the vertex with this one, we do have to do negative 2b over a. Actually, I said that all wrong. Negative b over 2a. And then once we find that's going to be the x part. Then we'll plug it into this expression to find the y part. So our b value is a negative 12, and our a value is 2 in this problem. So we have a negative in the formula, but our b is a negative 12 over 2 times a, and a is 2. So negative and negative means this is actually a positive 12 divided by 4, which is 3. So my x part of the vertex is 3. To find the y part, it's like you say, you could replace function of x with y. We're taking 2 times and we're replacing the x's with the 3. And you're going to type that into your calculator. And for time purposes, I've already done it, and it's negative 8. So my vertex is 3, negative 8. Okay, so the third thing I like to, once I've identified the vertex, I can say my axis of symmetry. Like if you were to fold the paper vertically, where would you fold it at? And it would be right at the middle apart, right? And each side would match exactly. So your axis of symmetry is x equals 3. From there, I like to go ahead and graph it, and then we can talk about the range, the max, the min things that we did above. So the first thing I would do is we're going to use this 3, -8 in our t-chart. Okay. And then I like to choose one number before and after x, or maybe 2 numbers before and 2 numbers after, as long as it's the same distance that you're hopping in each direction. And it helps you match up the y values, because remember, this is a parabola, so it should match up on each side if you move over the same amount from your x, from your vertex. So this will be an ordered pair: 3, -8, 1, 2, 3, down 8, 1, 2, 3, 4, 5, 6, 7, 8 is right there at the very bottom of the graph. If we were to plug in a 2 to that equation, we would say 2 times 2 squared minus 12 times 2 plus 10. Plug that into your calculator, and you will get a -6. You get the same thing when you plug in 2 times -4 squared times 12 times 4 plus 10. Plugging in that x value, you'll also get a -6. Pause the video, try it out, make sure you do. So when we go graph that, you would go over 2, down 6, which is right here, and over 4, down 6. And it looks kind of like this. It's not really supposed to be like a B. It's really supposed to be rounded out, even though it's really tight there. If you were to have done like 1 and 5, it might help you pull your parabola out just a little bit. So remember your vertex, is this a max or a min? Let me go ahead and answer that. Well, that's the lowest spot, so we would call that the min. Again, these are all just little things that we're learning about these parabolas, graphing these parabolas, that you will answer, not always all in one question. So you have to, when you're working on your homework, figure out how to identify if that's a max or min. Well, knowing that the vertex is this and then it opens up tells you that the min is at that 3, -8. Now we talk about range, and range we do have to indicate or show it in interval notation. And range deals with your y values, right? Axis of symmetry deals with the x values, range deals with the y values. And so we know that the lowest y value here was -8. So y's are greater than or equal to -8. And so if you think about kind of the number line like we did in when we were graphing inequalities, if you go this direction, you'd be going to -infinity, and if you'd be going upwards, you'd be going to infinity. So it's kind of taking what you did this way with inequalities, and you're doing it this way with your graph. So if x is greater than or equal to -8, we could include -8 in it, and it's going to go up to positive infinity, and that's how you'll indicate the range value for a parabola. Doing number 3. So number 3, your first term is negative, so this opens down. The second thing, my vertex, again, because it's in quadratic equation form, we get to find the x part, -b over 2a. Our a is a -3 and our b is a -24. So when you plug that in, you have a negative in the formula, -24 over 2 times a and -3. So when you simplify that, you'll get a -4. So my x part of the vertex is -4. We need to know the y part, and we do that by plugging it into the equation. So -3 times -4 squared minus 24 times -4 minus 43. Plug that to your calculator and you get a +5. So my vertex is -4, 5. right? This is your vertex right here for that one. Okay, so that's your vertex for this one. So from there, I might go ahead and answer my axis of symmetry because it deals with your x values, right? I'm gonna go ahead and write that this time. So it'd be -4. If I were to fold this graph at -4, it's supposed to match up on both sides if you were using a graphing tool and it was perfect. I like to graph after that on step 4. And with graphing, I don't just choose totally any number that I want. I always use my vertex part that I found, and I choose one before and one after it, maybe -5 and -3. And then I plug those values into that equation to solve. So -3 times -5 squared minus 24 times -5 minus 43. Plug that into your calculator and you get, did I write 5? Yes, I did. Okay, and you get 2. -3 times -3 squared minus 24 times -3 minus 43. When you plug that into your calculator, you get also a 2. If you move the same amount on the left and to the right, the y value should be the same because remember, if you fold this graph, those points should land right on top of each other. So let's go graph it. -4, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. So that's my vertex. But if I went to -5 up 2, or -3 up 2, that's here. And remember, it is opening down, right? It's pointing downward, so that's good. We've done well. Then from here, we need to identify, is that vertex a max or a min? This is a max because it's the highest spot. And then our range, remember your graph goes to -infinity up to +infinity, right? And so in this case, y needs to be anything less than that 5, because this is 5, the y value, so y needs to be less than or equal to 5. So we're going to go a little bit backwards, and we still read these from bottom to top, okay? This one we were reading bottom to top, so it's important that, like in this one, that you did put -8 to infinity and you didn't write it backwards, okay? Because we always do least to greatest, and that's also a thing maybe that helps you think about it. We're going least, so -infinity up to 5. We're including 5, so we put a hard bracket, and infinity, you can't include it. So this is the range in interval notation. So I encourage you maybe to pause the video, stop it, go back over those a little bit on your own. It's really important to know that really your vertex derives everything in this problem or in this section. The x part deals with the axis of symmetry. The y part deals with the range. Understanding your first term dictates if it opens up or down is a big deal. And max and min, just thinking is at the lowest or the highest spot of that graph. Okay, so now we have some application problems. So things that you can answer that actually deal with kind of like the vertex. Okay, so number 1 says the profit function P of X for companies selling X items is given by that equation. What value of X will maximize the profit? So remember your vertex, how do we find the X part in a problem like this? Well, we would use -b over 2a. And it just wants to know the X part. So our A value is a -3 and our B value is 96. So negative from the formula, 96 over 2 times A, and A is a -3. So calculate that, and that would be 16. So they were asking how many items is given to maximize the profit. 16 items. Number 2 says a ball is thrown upward in an initial velocity of 48 feet per second. If the ball started its flight at a height of 8 feet, then its height at time t can be determined by this. So all that is kind of extra information to help you understand how they generated this function right here, where S of t is measured in feet above ground and t is the number of seconds of flight. So in WebAssign, it's in the order that I believe we have right here in the notes. And it's important to kind of read each one because if it says determine the time it takes the ball to attain its maximum height, you have to know the x part anyways to even answer what we would call the y part. So your S of t in these problems are kind of like your y part. It's like the solution. It just looks different than your x's and y's. Your t that's here is kind of like your x part in that equation. Maybe that helps a little bit to understand why we probably would need to jump to D or B, because we can't really answer A without finding the x part first. So if I were doing this, I would have to use my negative B over 2A. So negative from the formula, and our B is a 48 over 2 times A, and A is a negative 16. When you calculate that, that's like 3 over 2. Since it's an ending decimal, you could use it like this, 3/2 seconds, or I think it makes more sense to say 1.5 seconds, as long as you didn't have to round it. You didn't have to change it by turning it into decimal. So this would be the x part of the vertex, basically. My y part would be plugging that in to the equation for like the t, the x. It's just a different letter. On those other problems, if you noticed, in the expression, these were x's. The only difference is they just write it kind of funky and it's a t and not an x, but it means all the same stuff. So negative 16 times 1.5 squared plus 48 times 1.5 plus 8. Just replace my t's. So plug that into your calculator and you're going to get 44. So remember they said S of t, kind of like your y part, is measured in feet above ground. So the ball would be at 44 feet. The maximum height of the ball is 44 feet. This one says determine the time it takes for the ball to hit the ground. So the height would have to be 0. So we would replace that S of t is like our height, kind of, right? Because that's the height. S of t, it kind of tells you that somewhere at feet above ground, the height. So we're just going to say, that's like saying 0 equals negative 16 t squared plus 48 t plus 8. And so to go find the time it takes for the ball to hit the ground, we would go use our quadratic equations. We have negative b plus or minus the square root of b squared minus 4 times a all over 2a. So my a value is negative 16, my b is 48, and my c is 8. So I'm going to plug that stuff in, and I'll let you work quietly while I work quietly. So if you need to pause the video, go through those, go through that. Double check. My math, make sure you got the same thing when you type it into your calculator. So what we'll notice here is that, kind of like the previous lesson that we did, I can't have negative time, so that's not gonna be a reasonable answer. So it's gonna say it takes 3.16 seconds for the ball to hit the ground. Problems like this, make sure you're just looking for rounding instructions so that you round appropriately.